It stares back at us, a massive crimson eye, swirling in the clouds of a distant giant. Visible through even the most modest telescope, it's a feature so iconic, so persistent, it has captured the imagination of astronomers for over 350 years. This is Jupiter's Great Red Spot, a storm the size of Earth. It rages in the southern hemisphere of the gas giant, its winds tearing through the atmosphere at over 400 kilometers per hour. But this isn't just a hurricane. It's not a fleeting weather pattern. It's a physical mystery, a marvel of turbulent motion, a masterpiece of planetary physics that has defied expectations for centuries. What keeps it going? Why does it rotate the way it does? And why, after centuries of dominance, is it slowly shrinking? This is the story of the most powerful storm in the solar system, and the bizarre physics that keeps it alive. To understand the Great Red Spot, we first have to understand its world. Jupiter is more than just the largest planet in the solar system. It's a world of extremes, made almost entirely of hydrogen and helium, with no solid surface. It spins rapidly, once every 10 hours, creating intense equatorial bulges and immense atmospheric forces. Its atmosphere is layered in bands, alternating stripes of light and dark clouds, each spinning in opposite directions. These bands are known as zones and belts, and between them are powerful jet streams, like highways of wind, wrapping around the planet. These winds don't follow Earth-like weather rules. On Jupiter, they reach speeds of over 600 kilometers per hour, and they don't dissipate easily. It's within this chaotic system that the Great Red Spot lives, trapped between bands, fed by differences in pressure and velocity. Not just a storm, but a system unto itself. The first recorded observation of the Great Red Spot dates back to the 1660s, over 350 years ago. Early astronomers, using primitive telescopes, noticed a persistent oval-shaped feature in Jupiter's clouds. For decades, it came and went, but by the 19th century, it had become clear this storm wasn't disappearing. It wasn't drifting off. It was enduring. It was permanent, or so it seemed. Over time, the spot changed color, deep crimson, pale salmon, sometimes even fading almost entirely. But it always returned, always persisted. When the Voyager spacecraft flew past Jupiter in 1979, it gave us our first close-up view. An immense storm, larger than two Earths side by side, spinning counterclockwise, bordered by powerful wind shears. Later missions, Galileo, Juno, and Hubble, revealed more. Layers within layers. Vortices surrounding the vortex. A storm embedded in a sea of turbulence. And yet, it still hadn't died. On Earth, storms are fueled by heat, pressure differences, and moisture. They form, they rage, then they fade. But the Great Red Spot doesn't behave like an Earth storm. It's more like a giant vortex, a spinning system of high-pressure gas. It rotates counterclockwise, opposite the direction of cyclones on Earth. And unlike hurricanes here, which are low-pressure systems, the red spot is high pressure, an anticyclone. Why does it last? The answer lies in Jupiter's physics. No solid surface. On Earth, hurricanes weaken when they hit land. But Jupiter has no land, only deeper layers of gas and liquid. There's nothing to slow the storm down. Immense size. The spot's diameter is massive. Even now, when it's shrinking, it's still wider than Earth. The sheer size gives it inertia, momentum, staying power, jet stream barriers. The spot sits between two strong jet streams that move in opposite directions. These streams form a kind of atmospheric cradle, trapping the storm, preventing it from drifting or unraveling. Energy from surrounding vortices. Jupiter is full of small storms. Sometimes they get absorbed into the red spot, feeding it new energy and momentum, like logs thrown into a fire. It's not just a storm, it's a self-sustaining machine, driven by the bizarre physics of a gas giant. Thanks to NASA's Juno mission, we now know that the red spot isn't just a surface feature. It extends hundreds of kilometers into Jupiter's atmosphere. It's tall, deep, a three-dimensional behemoth, rotating with a ferocity we can barely model. Infrared scans reveal temperatures inside are warmer at the base, cooler at the top, like a massive vertical column of swirling gas. Winds inside the storm can exceed 432 kilometers per hour, 268 miles per hour, whipping in wide, counterclockwise loops. The storm's center is calmer, like the eye of a hurricane, but the edges are violent, lashing against surrounding currents. It pulses, it breathes, it lives, and we still don't fully understand how. Why is it red? That's still one of the biggest unanswered questions. Some scientists believe it's caused by complex chemicals, like phosphorus or sulfur compounds, pulled from deeper in the atmosphere and exposed to ultraviolet light from the sun. Others suggest it's a result of ammonia reacting with unknown molecules, forming chromophores, color-giving substances unique to Jupiter. But the truth is, we don't know. The color changes over time. Sometimes it deepens, sometimes it fades. It's not constant, and it doesn't correlate perfectly with the storm's strength. It's a mystery within a mystery, a scientific riddle spinning in plain sight. Here's the strange part. The Great Red Spot is getting smaller. Over the past 150 years, it's shrunk by more than half. Once large enough to fit 3 Earths, it's now barely larger than one. Why? Is it running out of energy? Being starved by the atmosphere? Altered by climate shifts within Jupiter itself? We're still not sure. But we do know that the storm is becoming more circular, and sometimes it sheds small flakes of material, like pieces breaking off a whirlpool. And yet, even as it shrinks, it remains powerful, still spinning, still glowing, still holding its place in the planetary chaos. Some believe it could disappear entirely in the next century. Others think it may stabilize or regrow. Like everything else about the red spot, the ending is uncertain. The Great Red Spot isn't just a storm. It's a cosmic monument, a symbol of planetary dynamics pushed to the extreme, a reminder of how little we know about weather beyond our own sky. It's taught us about fluid mechanics, atmospheric chemistry, turbulence, and the role of magnetic fields. It's challenged our models, surprised our instruments, outlasted generations of scientists. And for centuries, it's been a beacon in our telescopes, a living, swirling testament to the strangeness of the solar system. It is the eye of Jupiter, and it is still watching us. Tonight, if you point a telescope at Jupiter, you might catch a glimpse of it, a reddish oval, just south of the equator, slowly drifting across the cloud tops. You won't hear it. You won't feel its winds, but you'll be looking at something ancient, a storm that began before humans had electricity, before the telescope was perfected, before Newton even described gravity. And yet it rages on, silent, colossal, unstoppable. The Great Red Spot is not just weather. It's physics, poetry, and persistence, all wrapped in a storm that has become one of the greatest wonders in the solar system.